Uh, so, hello. I think this is my second or third live, and what I'm planning in this video is to give you an overview of Teradata architecture, which is used as an transformation database for analytics. And so here we go. So in this session, in this live session, I'm going to talk about the agenda of this which is introduction and Teradata architecture. So introduction about the Teradata and its architecture, right? So Teradata is a relational database management system. That means uh, whatever the data that is stored in it is in the Teradata DB basically consists of rows and columns, and so structured data comes under this part where we are storing the structured data. And since it is used for the analytical purposes, so there are world's largest commercial databases you know mm, are run on this Teradata platform, and is also used for enterprise data warehousing. Mm, so that means that enterprise data warehousing means that your organization also uses these Teradata RDBMS to perform some analytical query on the database. And so it runs on single or multiple MPP nodes, single node or multiple nodes. So we will come to that later. And it uses parallelism to manage gigabytes of data. So we will also learn about what is parallelism. Okay. Going to the next part is which all are the other stakeholders which are using the Teradata application. Those are the airlines, retailer, banks. These uses RDBMS as a Teradata to store their customers database data in their database, so as to perform some analytical queries, as it uses some single or multiple that MPP architecture. It has some MPP architecture. Using that, leveraging that kind of technology, the query, right? And it helps in the is you have importance of Teradata is there are limited. I'll tell you the most important advantages of using the Teradata system is the parallelism, right? And it has a concept of optimizer. So said that optimizer makes an explain plan. So yes, so using that explain plan, the amps amp node present in the Teradata architecture gets the rows get distributed over the amps, and that particular decision is taken care by the optimizer during the parsing of the query. Once it passes the query, then it also you know gets to know like which amp needs to be hash and if. So yeah, and then so it's high availability just because there are multiple nodes, multiple amps are present in Teradata system, and that is why it is highly available. If one of the node gets failed because of any disaster scenario, then other nodes are available at that moment to perform some queries on those data. So that is why Teradata being one of the have the giant architecture, and it helps in the processing of complex queries. So going through the architecture, it has three architectural components. So first is the parsing engine, second being the Binet, and third being the amps. So parsing engine is like the leader of the complete architecture of Teradata. It takes all the decision after passing the query. It prepares an explain plan for the uh, query that a client has already a client wants to query something, and the parsing engine is the leader who builds an explain plan and uh, passes the information via Binet, and all those amps are you can say like the co-workers, and they gets the responsibility to divide the rows by themselves, and then they perform uh, and then they retrieval and all those things happens through those amps only. So they have one data disk storage where they store the data in a in a parallel fashion. All the data is stored in the amps so that there is no load. Also you can say like parsing engine is something like there's a concept in Kafka also. So I'm actually not able to recall that concept, but it's something like a load balancer. Yes, kind of load balancer where you share the data, right? You share the data across all the nodes, and so that there is no there is no load on a particular node, and then processing also gets faster. So what are the activities of parsing engine? So the parsing engine will check the user's SQL syntax. It will check for the user's access rights. So it's the first point of contact once you are querying in the Teradata database. So there the parsing engine will check the syntax. It will check for the user's access rights. It will build an execution plan. Right? It will build an execution plan and send the plan across all the amps, and it also manage individual sessions up to 120. So individual sessions up to 120, that means up to 120 people can or the clients can at the same time they can query, or their sessions can be created. So 120 sessions at the particular moment of time can be handled by the parsing engine. And so what it does, it takes the query, like it creates the explain plan. It passes the information, all the information gets passed via Binet. It gets stored to all the amps, and once the particular data is found in any of the amps, the retrieval happens, and it's the responsibility of a parsing engine processor to send back whatever the data has been retrieved to the user. So this is a complete flow, right? Going forward, so there's a concept of amps in Teradata, which is also known as access modular processor. So what is the use of those access modular processor is to store and retrieve rows to and from the disk. So there is a concept of disk also. There is an amp which processes, but whatever the records are stored, that is not stored in amps, but there is a disk, virtual disk associated with each of the amps, right? So what is the function of an amp is to store the data in its associated virtual disks, right? So there is a joint processing, there is a recovery processing, lock management. These all things are taken care by the amps, right? Going forward, so yes, so this is very this is a very genuine thing that you should not tell, like Teradata stores data like in one of the AMP you will get all the data associated with table 1, and then uh, data associated with table 2 or table 3, and like if there are 4 AMPs it won't store data like table 1, table 2, table 3 and table 4. This is very wrong concept. So first of all, it stores the data. Suppose in table 1 there is 4 row of data, right? So it will store row 1 uh, in the first AMP, second, third and fourth, like that it happens. Going forward, we have Binet, which is also known as message passing layer. So it acts like postman. So just for an instance, suppose that your Teradata system is a source and your amps are the target. So to connect the source and the target, there is a Binet, which is also known as message passing layer. So why is it called message passing layer? Is because it passes whatever the explain query has been prepared uh, by the parser, which was your parsing engine, to the amps. So it's like a connect. It builds a connection between both the nodes, right? So Binet is also known as dual reductant fault tolerant bidirectional interconnect network that enables automatic load balancing of message traffic, automatic reconfiguration after fault detection, scalable bandwidth as nodes are added. So these three things are very common. So it works as a load balancer, right? Because once the message is passed via Binet, so automatically there is a configuration that it will uh, help in the load balancing of message traffic. Suppose it handles 120 sessions per user. No, it handles 120 sessions. So suppose there is a quite a lot of load in particular one table in which multiple users are querying. So it's the responsibility of Binet to load balance the particular traffic according to the explained plan that is created by Parsing Engine. It's the work of a Binet to automatically load balance. And if suppose ki there are 4 amps, in case of any fallover or any kind of fault or disaster, there is always backup of that amp is present. So in case suppose the copy is present in another amp, and in case the suppose this is my left hand and this is my right hand, suppose this left hand stops working, the data is already stored in this right hand, and then it will take the responsibility of this. So Binet is also responsible for broadcast, multicast, point-to-point communication between node and virtual processor, merging answer sets back to the parsing engine and making Teradata parallelism possible. So this is Binet. Going forward, we have query processing. So how does that query processing happen, right? So the parsing engine checks the user SQL syntax. So suppose I am the user, I am trying to prepare a query and I'm trying to what I'm planning is to query some kind of table. So in that case, what parsing engine will do, it will first check for my SQL syntax. It will check for my user security, right, whether I have the authority to access that particular table. So that comes under parsing engine. Parsing engine comes up with a plan for the amps to follow. So as it is a leader, so what it will decide is to create an explain plan. It will pass via the Binet will do the load balancing according to whatever the explain query has been planned by the parsing engine, and the amps will follow whatever the direction is given by the parsing engine, and whatever Binet has passed to all the load balance to all the amps. Amps follow the plan and it retrieve the data requested. So whatever the data has been requested by a client, so it will provide whatever the information that is required, and then it passes to the final user once the data is extracted. So each parsing engine can handle up to 120 sessions in parallel. So there are suppose 120 guys who are trying to access a particular table, which is common for all 120. Then parsing engine has that much of capability that it can maximum handle 120 sessions. So that part is clear, and each session can handle multiple requests. Okay, so the Binet can handle all message activity in parallel, and each app can perform up to 80 tasks in parallel. So this is one thing that in parallel each app can perform 80 tasks in parallel. So that's a very big thing. And so yeah, so these are very flexible. So amps can perform 80 tasks in parallel. All amps work in parallel to service any request, and each amp can also work on several requests. So 80 tasks it can perform, each amp can perform up to 80 tasks and can work on several requests in parallel. So all these things happens very parallelly. So it takes very minimum time to retrieve the record, whatever has been requested by the client. So data distribution. Coming to the data distribution, Teradata do not have concept of pre-allocated table space. Pre-allocated table space. So Teradata do not have concept about this. Teradata uses hash partitioning and distribution to randomly and evenly distribute data across all amps. So it's a very good point that Teradata distribute data very evenly across all the amps that it has with it, right? And it uses hash partitioning. So each amp is responsible for a subset of the rows of each table, and evenly distributed tables result in evenly distributed workload. The data is not placed in any particular order, right? So this is one thing. Going forward, primary index. So primary index, the mechanism used to assign a row to an amp. So a primary index is something, suppose in a table some ID is there which is the PI of that particular table. So to assign a row to an amp, it uses a primary index as its mechanism. So it may consist of a single column or a combination up to 16 columns. So this is a very good point that not only primary index is selected or is a particular, that is only the criteria to assign a row to an amp, and but it has but it can combination of 16 columns which can be used to decide which amp needs to be uh, taken care of, can work and function like that for the function. So PI plays three roles in the data distribution, as it is said that amps are selected according to the whatever the primary index is there in that table. Fastest way to retrieve data, yes, obviously primary index is the fastest way to retrieve data. So suppose you have 5 rows, and 5 rows are unique, right? And 5 have unique IDs as a primary index, but you are trying to query the tables using some other keys apart from primary key. So in that case the query comparatively takes much time as compared to uh, querying the primary index directly, right? Because it will take very least time for the parsing engine to prepare a explain query to decide which particular amp has that particular primary index stored in it. So this is as simple as that. Now going forward, creating a primary index. So primary index is created at the time of the table creation, and changing the primary index requires dropping and recreating the table. So this is very good point. In case of MySQL as well, whatever I know right now is that primary index requires dropping and recreating the table. Suppose there is a table and it has a primary index which is some id. So in case you want to change the particular student id to some different id, so in that case the particular table which may be named as abcd has to be dropped, right, has to be dropped in order to create a new one. So this is also a good point. Now there is one thing, there is a difference between primary key and primary index. Not to be confused, primary key is the logical concept of data modeling, while primary index the physical mechanism for access and storage. So Teradata does not need to recognize each table must have exactly one primary index. So we will take primary index. So in case of Teradata, not to be confused that primary index is one of the driving factor, which is the physical mechanism for access and storage. And primary index, we have two types of primary index, which is unique primary index and non-unique primary index. So what is unique primary index? So if the index of a particular column is unique, we call this UPI. And if the index choice of the column is not unique, we call this as a non-unique primary index. So going forward, suppose the primary index of a row is 1002, right, the value of the primary index is 1002. So how it will be placed on an amp, that particular row of that particular primary index, is that first it will be converted into a row hash, right, and then it will be, there will be a creation of hash map, and then according to the suppose the after being created in the hash map, it will directly land to the buckets. So suppose there is 3 amps, but amp 2 has the value of row hash as 5. So I'll tell you in a more simpler way. So suppose there are 3 amps. Each of the amp has got some unique row hash value, right? And whenever you are querying some a table, so what the parsing engine will do, it will first search for the primary index value. It will convert that into hash map. It will take the row hash value of that particular primary index. There is a association of primary index to a row hash, so it will take the row hash of that particular primary index value, and that row hash, the value of that row hash is uniquely connected with the amps. So suppose there are 3 amps, and there are 3 row hash value will be there, which will be unique to each one of the amps. So accordingly it will store all the data. The primary index value will have a hash map creation. It will get a row hash value, and the row hash value has an associated amp, and in that amp that particular value will be stored. So that happens. Going forward, So placing rows on the amps. So suppose there are two amps, it will contain row hash and the uniqueness of the value. So uniqueness of the value is your primary index. Right. So these two things will be there. Going forward, it will be partition primary index. So there is a concept of partition primary index in Teradata system. So why partitioning is important? So partitioning is important when we are doing some analytical queries on the database. So at that time, what it does, it partition the records based on the column that we provide, on what columns the requirement as a client we have, and then we can sort the rows ID what we want. So suppose giving you a very simpler idea on this is, suppose you have a table. In that table you have um, uh, IDs. In the table you have IDs, and you have some date column as well. So suppose you want to partition the data based on the IDs, and then you can sort on the basis of date in descending or ascending order, so that you can able to so you can able to get the latest record as well when you do the partition. So suppose you do the partition for that particular ID. Suppose the value of the particular ID is 5, and 5 rows are associated with that IDs. But when you are doing, and correspondingly 5 date columns are also there, values of those date columns. But when you are doing the partition and trying to order the order the date, sort the date according to the descending or ascending order. If you do the descending, then the latest one will be picked up in that case. So for all the data that is present in the table, you can get the latest date value of that particular ID, or right, like that it happens. So there are three types of partitioning: simple partitioning, range partitioning, and case partitioning. We'll go ahead and see. So suppose you are doing when you are creating a table, at that time if you mention partition by and give a pass a particular column in that, so it will so each amps will sort the rows on the basis of the department number, as you have already partitioned. You have given that function partition by. In the second case, when you are you have written partition by, and you have put the function as range, and then order date between this and this and interval. So what it will do, it will sort the rows on each amp by order date and create a different partition each day, because they have also passed some interval kind of thing. Because I'm not sharing my screen, so maybe that is not understood, so that is okay. There are a couple more of things. Secondary index. Table can have 0 to 32 secondary index. Unique secondary index and non-unique secondary index is also there. Then we have non-unique secondary index is also there. So yeah, so that's all for this time, and hope when I will do the second live session, then I'll cover the joins in Teradata.